Here's the topic in engineering data analysis design analysis of single factor experiment. Completely randomized single factor experiment. The tensile strength. A manufacturer of paper used for making grocery bags is interested in improving the tensile strength of the product. Product engineering thinks that tensile strength is a function of hardwood concentration in the pulp, and that the range of hardwood concentration of practical interest between 5 and 20%. A team of engineers responsible for the study decided to investigate four levels of hardwood concentration: 5%, 10%, 15%, and 20%. They decided to make up 6 test specimens at each concentration level using a pilot plant. All 24 specimens are tested on a laboratory. The tensile strength of a metal is essentially its ability to withstand tensile loads without failure. Ductility, on the other hand, measures a material's ability to deform under tensile stress. Here's the observation on the hardwood concentration. In 5, there's 7, 8, 15, 11, 9, 10, and it's a total of 60. While on the 10, there are 12, 17, 13, 18, 19, and 15 with a total of 94, and an average of 15.67. While on the 15, there are 14, 18, 19, 17, 16, 18 with a total of 102 and an average of 17.00. While on the 20, there are 19, 25, 22, 23, 18, and 20 with a total of 127 and an average of 21.17. In the total, there are 383 while on the average is 15.96. Analysis of variance. Suppose we have a different level of a single factor that we wish to compare. Sometimes, each factor level is called a treatment, a very general term that can be traced to the early application of experimental design methodology. The agricultural science, the response for each of the treatment is a random variable. Linear statistical model. So you can see in the treatment, there are 1, 2, etc. A. While on the observation, there are y prime, the total, and the average. Overall mean is equals to mu plus random effects plus random error component. Overall mean is a random variable denoting the ij, the observation. Mu is the parameter common to all treatments called the overall mean. While on the random effects, it is a parameter associated with the ith treatment called the treatment effect. And lastly, the error component is the random error component. The treatment defines a population that has mean mu, consisting of the overall mean mu plus the effect T1 that is due to the particular treatment. We will assume that the errors component are normally and independently distributed with the mean with 0 and variance 0 2. Therefore, each treatment can be thought of as a normal population with mean, mu, and variance. The ANOVA partitions the total variability in the sample data in the two components part. Then, the rest of the hypothesis is based on a comparison of two independent estimates of the population variance. The total variability in the data is described by the total sum of square. Sum of square T is equals to the summation of A I equals to 1 and the summation of N J is equals to 1. The overall mean is minus y bar slash etc. N square. The partition of the total sum of squares is given in the following definition. Sum of square T is equal to the sum of square treatments plus sum of square E. The expected value of the treatment sum of the square is E. Sum of square treatments is equals to A minus 1 in square plus N. Summation of A I is equals to 1 and the random effects square. And the expected value of error sum of square is E. Sum of square E is equals to N minus 1 square. ANOVA test. FO is equals to sum of square treatments divided by A minus 1 divided by sum of square E divided by A multiplied by N minus 1. And FO is equals to MS treatments divided by MSE. The sum of square computing formulas for the ANOVA with equal sample sizes. Sum of square T is equals to summation of A I equals to 1 and summation of N J equals to 1. The overall mean square minus Y square divided by N. And the sum of square treatment equals to summation of AI equals to 1 and yi square divided by n minus y square divided by n. The error sum of square is obtained by subtraction as sum of square E is equal to sum of square T minus sum of square treatments. Analysis of variance for single factor experiment. Fixed effects model. The source of variation is the treatment and the error. Sum of square is in the treatment there are sum of square treatment in the error is sum of square E. While on the degree of freedom in treatments there are 1 and in the error n minus 1. The mean square MS is treatments while on the error is MSE. While on the FO MS treatments divided by MSE. Example, this experiment is completely randomized design. We can use the analysis of the variance to test the hypothesis that different hardwood concentration do not affect the mean tensile strength of the paper. The hypotheses are design and analysis of single factor experiment. The analysis of variance. Sum of square T is equals to summation of 4i equals to 1 and summation of 6j equals to 1. The overall mean minus y squared over n. Sum of square T is equals to 7 squared times 80 squared plus 223 minus 383 square divided by 24 and it is equals to 512.96. Sum of square treatment is equals to 4 summation of 4i equals to 1. yi square divided by n is minus y square divided by n. The SS treatment is equals to 60 square plus 94 square plus 102 square plus 127 square divided by 6 minus 383 square divided by 24. And the SS treatment is equals to 382.79. So P is equals to PF 320 greater than 19.60 and 3.59 times 10 negative 6.